Hello everybody and welcome to my 20-second video. This is on the quaternary algebra with Karnaugh Maps. I'll be going through a Karnaugh Map method of simplifying a function and an algebraic method of simplifying a function. Well, this is not my algebra, this is the reference where I got the algebra from. It's an n-valued algebra. Like I say, I'll be presenting it in the quaternary case. So let's get to it. These are the functions of the algebra. This is the minimum function, which takes the minimum value of whatever is on its inputs A and B here. This is the maximum function, takes the maximum value of whatever is on its inputs A and B here, A plus B. Maximum function is denoted by a dot. Sorry, the minimum function is denoted by a dot. The maximum function is denoted by a cross, plus sign. Here we have the Unary operators. A plus is A plus 1 modulo 4. A plus plus is A plus 2 modulo 4. A minus is A plus 3 modulo 4. Now these are the 4-valued Unary operators. These are the 2-valued Unary operators. An equals n if A equals 0 and a 0 everywhere else. A plus n is n if A plus is a 0 and a 0 everywhere else. A plus plus n is an n when A plus plus is a 0 and 0 everywhere else. And A minus n is n at A minus equals 0 and a 0 everywhere else. N can assume the value of 1, 2 or 3. Here we have some algebraic rules. An plus max, A plus n max, A plus n max, A minus n equals n. Like I say, n equals 1, 2 or 3. A max A plus max A plus plus max A minus equals 3. A minus 1 max A plus plus 2 max A plus 3 equals A. A1 max A minus 2 max A plus plus 3 equals A plus. A plus 1 max A2 max A minus 3 equals A plus plus. A plus plus 1 max A plus 2 max A3 equals A minus. 1 min A max 2 min A max A equals A. A max A equals A. 3 min A equals A. 1 min A3 equals A1. 1 min A2 equals A1. 2 min A3 equals A2. A1 max A2 equals A2. A1 max A3 equals A3. A2 max A3 equals A3. So note that A1 max B1 equals A1 max B2 equals A2 max B1 equals A1 max B3 min B3 equals A3 min B1. Sorry, these are the minimum functions, not max. So this is because the minimum value of 1 and 2 is 1 here, and similarly minimum value of 1 and 3 is 1. So you can safely raise these variables to a higher n value and it still be able to equal A1 and B1. Similarly for A2, min B2 equals A3 min B2 equals A2 min B3. Factorisation, A min B max A min C equals A min B plus C max C. Right. So these are the Karnaugh maps that I'm going to be using to simplify an expression f. This is Karnaugh map f3, Karnaugh map f2, Karnaugh map f1. On Karnaugh map f1 we have the 2-valued Unary operators a1, a minus 1, a plus plus 1, and a plus 1. And we have the 4-valued Unary operators a minus, a plus plus, and a plus. Now, same thing for b. Now, not A, I'm using not A is because if this is not A, then these two columns, three columns must be A. Similarly, if A minus is not A minus, then these three columns must be A minus. A plus not. Similarly, these three columns, and A plus these three columns. Same for B, just with rows instead of columns. Now, in this case, F1 only deals with the zeros and ones, so n equals a 1 in this case with the two-valued Unary operators. Karnaugh Map F2 have the same two-valued union operators except A equals 2. Same for B. N equals 2. N equals 2 there. And A minus covers 0 and 3. A plus plus covers 1 and 2. Sorry, A plus covers 1 and 2. A plus plus covers 0 and 1. And A covers 2 and 3. Same for B. F2 only deals with logic 2s, 0s and 2s. And F1 only deals with 0s and 1s. In Karnaugh Map F3, that only deals with 0s and 3s. And the two-valued union operators are the same except where n equals 3. Same for B. And A minus covers 1, A plus plus covers 1 column, A plus covers 1 column, and A covers 1 column. Same for B except for the rows. Now the idea of the Karnaugh map minimization is to start at Karnaugh Map F3 and work downwards to cover as many as you can with the expressions of F3 in F2 and F1. Similarly, F2 you cover as many expressions as you can in F1 with F2, and F1 just sorts itself out. If you're using purely four-valued union operators in F3, the term has to appear in all lower Karnaugh maps, and if you're using purely four-valued variables in F2, it has to appear in F2 and F1, and F1 just sorts itself out. Right, so see what we've got. So this is example 1. This is table 1 in the reference I showed you at the beginning of the video. Here I've got the inputs A and B, the output F, and I'm going to code F with F3, F2 and F1. These are the Karnaugh maps codings for Karnaugh Map F1, Karnaugh Map F2 and Karnaugh Map F3. For a 0, F3 and F2 and F1 are equal to 0. For a 1, F1 is a 1, F2 is a 0 and F3 is a 0. For a 2, F1 is R, a redundant state R, F2 is 2, F3 is 0. For a 3, F1 is a redundant state, F2 is a redundant state R, and F3 equals 3. And if F is a don't care state, 0, 1, 2 or 3, F3 and F2 and F1 are both R's. The value of R in F1 can equal a 0 or 1. Value of R in F2 can equal a 0 or 2. Value of R in F3 can equal a 0 or 3. Now I've written the term in for each row of the function. So for example A2 here, F is a 2 here, so the expression is A2 min B2. How you determine the term is, what do I have to do to A and B to get it to a 0? Well, in this case I don't have to do anything, so it's A2 and B2. For this row, F is a 3, so you're dealing with 3's, n equals 3. And for A, well, I have to add 2 to 3 to 2 to 2 to get it to a 0, so it's A plus 2 modulo 4. And what I have to do to a 1 to get it to a 0, I have to minus 1, so it's B minus 3, minus and plus 3. Right, so each term is a logic state at that particular row and a 0 everywhere else, and you connect these terms together using the maximum function. Right. So here we have the functions, the Karnaugh maps for the function, in example 1. So here starts at Karnaugh map F3, and this coordinate here is a 3, and the term is A and B in B3. This is A here, this is B3 here. I can use A because it's covered in all low Karnaugh maps. Here, A3, A and B in B2, and A in B1. Now these are redundant states because I'm looping R's here, and I'm already looping a 2 there, and I don't have to loop the R's there. So this is a redundant state. But you have to make sure that it's included in order to make that A an A. And if you can't, you have to make it an A plus 3. So it's just make sure it's available in all 3 Karnaugh maps. And B3 sorts itself out. It's B2 here instead of B3. It's B1 here instead of B3. For this coordinate Karnaugh map, I'm using 2 4-valued Unary operators. So I'm using B++ and A plus here, and I'll put a 3 in front of it because I'm only using 4-valued Unary operators. So, and again, if you have to make sure that the term appears in all in F2 and F1 all low Karnaugh maps because I'm using 4-valued Unary operators. So A plus and B++ appears here, and because I'm using 4-valued Unary operators, I place a 2 in front of it because it only deals with 0s and 2s, and it appears here A1 min A plus min B++. That covers that, and I have to put a 1 in front of it because the Karnaugh map only deals with 0s and 1s. Right, so that's Karnaugh map F3. F3 equals 3 min A plus min B++ max A min B3. Right, so yeah, for Karnaugh map F2, right, I haven't looped, I've covered these loops here in F3, but I haven't covered A2 min B minus. So this is A2 here, column, B minus covers 0s and 3s here. Now I've got to make sure it appears in F1, so here it appears here in A1 min B minus instead of A2 min B minus. So you've got A1 here, and not B minus is 0, 2 and 3 here. So for Karnaugh map, that completes Karnaugh map F2. Karnaugh map F1, I think we've covered everything by using 3 and 2 and working downwards. So Karnaugh map F1 is 1 and A plus min B++ max A1 min B minus, which is these 2 expressions here. I don't have to include that because that's a redundant state. F2 is 2 min A plus min B++ max A2 min B minus, these 2 expressions here. I don't have to include this because this is a redundant state denoted by an R. And this F3 equals 3 min A plus min B++ max A minus min B3. Right. These are the Karnaugh map expressions for example 1. So F1 is this, F2 is this, and F3 is this. F equals F1 plus F2 plus F3. And so this is F. What have I done here? Yeah, this is F1, this is F2, and this is F3. So I've factorised the 1, 2, and 3 here for A plus and B++. Left A min B3 alone. Factorised the A1 and the A2 here, B minus. So 1 max, 2 max, 3 equals 3, and 3 max A plus min B++ equals A plus min B++. and of course A1 max A2 equals A2 min B minus, and I've left that one alone, A min B3. So that's the Karnaugh Map method for getting the simplifying the expression f. Right. So this is an algebraic minimization for example 1. Here we have the expression f here, and the redundant states, the r's here and here. So what I've done is I've taken all these expressions here in f and some of the redundant states here to perform part of the function f. So for example 14 a1b++ is there. So for example number 1, a1 min b plus 3 is a1 min b minus 1, minus 3. So I've changed the 1 to a 3 there, and similarly here for 3, for example a1 a min 1 min a minus 1 min b plus 1. I've done a minus 2 min b plus 1. So I've changed the n value to 2 there from 1, and you can do this throughout the expressions. The reason you do this is because you can factorize terms and change the 2-valued Unary operators into 4-valued Unary operators. So for here for example I'm going to factorize a1 here, a minus 2 here, a plus 3 here, b3 there, and a2 there. So let's have a go. So yeah, as I said, I'm factorising the a1 there, b plus 1 max b2 max b3, factorise a minus 2 there to give that, a plus 3 there, b3 there, and a2 there. So because these are the same, b plus 1 max, b2 max, b minus 3, I can factorise the a's there to give that. I've left these two alone. So this term here equals a plus, this term here equals b plus plus, this term here equals a, and this term here equals b minus. So then we have the result is f equals a plus min b plus plus max a min b3 max a2 min b minus. Right. I have to say I wouldn't attempt this method of minimization by algebraic method. If you want to know how I did it, well, I cheated and worked backwards from the answer. So I would recommend you use the Karnaugh Map method and not the algebraic method. This is just to demonstrate how it's done. Right. So here we have example 2. This is table 2, which I gave in, which is in the reference which I gave at the beginning of the video. This is table 2. Here we have inputs A and B, F, F3, F2, F1 for coding F, and I've written the term in here, same as before. So for example, here I've got a 3, so it's a minus 3 min b plus plus 3 and equals 3. And what do I have to do to a to get it to a 0? I have to minus 1, so it's a minus 3. And what do I have to do to 2 to get it to a 0? I have to add 2, so it's b plus plus 3. So all these terms are valid for one row of the truth table, and you connect the terms together using the maximum function. For coding F equals F3 max F2 max F1. Right. use the Karnaugh Maps for example 2. So we'll start the Karnaugh Map F3 as we did before. So this logic state is of 3s and 0s, and this term is a++ min b++ 3. I'm using a++ here because it appears in here, not yet, there, these two rows here, and here. Is that right? Where have I gone? Yeah, there, and there, and there. So I've changed the 3 to a 2 here because n equals 2 here and 3 here. I've changed n to 1 here because n equals 1 here. Yeah. So again, these are redundant states because I'm looping r's here, and this one here is already all looped, so I don't have to record it, so it's a redundant state. And here, this is a redundant state because I'm looping these, which is already in a loop, so that's a redundant state. But like I said before, you have to make sure that any term appears in F3 also appears in F2 and F1 to be valid. So you don't include these in the expression for F1 and F2, but you have to make sure they're there. So for this coordinate in the Kanima map here, this 3 equals 3a plus min 3 min a plus min b. I'm using purely 4-valued union operators here, so I have to put a 3 in front of it, and this appears here a2 and a plus min b, which is here, these 4 loops, these 4 coordinates here, and I have to include a 2 in the expression because it only deals with the 0s and 2s, and I'm only using 4-valued union operators. And it appears here 1 and a and b, which is this loop here. Knock out that row and that column. So again, I have to put a 1 in front of it because it's only deals with 0s and 1s. So, and it's purely 4-valued union operators. Okay, so that covers F3. For F2, I haven't looped these 4 loops here, these 4 coordinates here. So that is 2 and a minus and b minus. It's a 2 in front of the expression because it only deals with 0s and 2s, and I'm only using 4-valued unary operators. And this appears here in our Karnaugh map F1, 1 min b minus min b minus. And that is that loop there, and those loops there. So that, because it appears in F2, it has to appear in F1 as well, but I have to put a 1 in front of the expression there and a 2 in front of the expression there. So for a Karnaugh map F1, again we've covered all the ones from expressions from F3 and F2. So F1 equals 1 min a plus min b max 1 min a minus min b minus. F2 equals 2 min a plus min b minus max 2 min a minus min b minus. And F3 equals 3 min a plus min b max a plus min b plus 3. Right. So here we have the Karnaugh map expressions for example 2. This is F1, this is F2, this is F3. And as before, F equals F1 plus F max F2 max F3. So F1 is here, F2 is here, and F3 is here. So factorised factorised the 1, the 2 and the 3 there for a plus b. I've left that alone, and I've factorised 1 and 2 here Yep, 1 or 2 here for A minus, B minus. And I've left A plus plus min B plus plus 3 alone. Right, yeah. So 1 max 2 max 3 equals A. 1 max 2 max 3 equals 3. 3 min A plus B is A plus plus B. Left that alone. 1 max 2 is 2. So that is 2 min A minus min B minus. So, right, that's the expressions for Karnaugh map F2. Here we're going to go through the algebraic minimization again. Here as before I've written in the F. This is the terms of F, which is in table 2. These are the redundant states. And I've included some of the redundant states. You can choose to include some of the redundant states or not, it doesn't matter. But you have to include all the terms of F. So here, again, number 6. Here's number 6 is A plus 1 min B plus plus 2. I've changed that 1 to a 2 here to give A plus 1 min B plus plus 2. And similarly, 16 here, I've changed that 1 to a 3, and similar process for the rest of them. Here I've put a 2 in front of this whole bracket here. That is because 8, number 8, is A2 min B2, but I've changed it to A min B3. So 2 and A, 2 min A3 min B3 equals A2 min B2, so I haven't changed the function, and all of these are unaffected by the 2 in front of that, because the maximum value is 2 in these things, in these expressions. It just means I can factorise the A3s here. So what I'm going to do is I'm going to factorise the A plus 1s here, A2s here, A minus 3s here, B3s here, and inside the bracket of the 2 I'm going to factorise the A plus 1s there, the A plus 2s there, and the A3s here. So F equals this. So I've factorised the A plus 1 there, the A2 there, the A minus 3 there, B3 there, 2 brackets, factorise the A plus 1 there, the A plus 2 there, and the A3 there. Now these are the same, A plus plus 1 max B plus 2 max B3. So I've factorised the A plus plus 1, the A2 and the A3 there. Yep, there. And what have I done with that? These are the same here, so I've factorised the A plus 1, the A2 and the A3 there, and I've left that alone. So F equals this, so this equal to A is equal to A plus plus, this is equal to B, that is equal to A plus plus, this is equal to A minus, and this is equal to B minus. So this is the expression for F. A plus plus min B, max A plus plus min B plus plus 3, max 2 min A minus min B minus. Right. Here we have example 3. This is another function. This isn't included in the reference at the beginning of the video, but I've just thought I'd put it in to show a few don't care states in the table. So here we have inputs A and B. This is the expression f, x. X can equal as a value of 0, 1, 2 or 3. There's a few in there, and 2s and 3s and 1s. So I've written the term in here. Again, what do I have to do to the term to make it a 0 here? So this is a 3, so n equals 3. It's a plus plus 3 min b3. So I have to add 2 to a to get it to 0. So it's a plus plus. And I don't have to do anything to b to get it to 0, so it's b3. So again, the f equals f1 max, f2 max, f3. And for the don't care states, I've just left it open with the value of n. N can equal 1, 2 or 3. If n equals 0, then you just get 0. Right. So this is a Karnaugh Maps, for example, example 3. Again, we're sat at Karnaugh Map F3, and here I can loop an entire column. So this is a plus plus 3. I can't use a plus because it isn't available here or here. So I have to use a plus plus 3 instead of a plus plus. I have to use the two-valued Unary operators. If you're only using two-valued Unary operators, the term is local to whatever Karnaugh map you're using, and you don't have to make sure it's available in lower Karnaugh maps. So this is a plus plus 3, this is local to a3, and it doesn't appear in any other Karnaugh maps. So here for Karnaugh map F2, again, I'm only using two-valued Unary operators, a2 min b2. This is a2 here and there's b2 here. So again, it's local to the Karnaugh map. I don't have to make sure it's available in F1. And here, Karnaugh map F1 just sorts itself out. So I can loop the a plus there, min b minus 1. So that's a plus, that's not a plus, that's a plus. This is b minus 1 here. So F1 equals a plus min b minus 1, F2 equals a2 min b2, and F3 equals a plus plus 3. So here we have the Karnaugh map expressions for example 2. F1 is that, F2 is that, F3 is that. F equals F1 plus F max F2 max F3. And so F is just the maximum of these values. A plus plus 3 max A2 min B2 max A plus min B minus 1. Here we have the algebraic minimization for example 3. These are functions of f, the expression terms of f. These are the redundant terms, and these are the don't care states. Here I've written the term in n where n equals 1, 2 and 3 here. Similar for here, 1, 2 and 3, and n equals 1, 2 and 3 here with the same two-valued Unary operators. So the same four-valued Unary operators. Okay, so again you don't have to use r's or x's. You can use choose them to suit. So, but I've included some of the x's here. So again, I haven't changed any n values here. They're all 3's. Number 1, I've changed that to a 2. Number 6, I've changed that to a 3. So what does this mean? Well, I can factorise the a plus plus 3 here for those 4. Factorise the a minus 1's here and leave that alone. So let's see what it does. So here, yeah, as I said, f equals a plus plus 3. I've factorised this term here. I left the a2 min b2 alone. I've factorised the b1 here. So b3 max b plus 3 max b minus 3 max b plus 3 equals 3. And this term equals a. plus, yeah, A plus. 3 min A plus plus 3 equals A plus plus 3. So we'll have the result here. Those two go down there. Right, I think that concludes the video. Just like to say I hope you've enjoyed it. Thanks for watching. Bye.